trucks and you make the big grades. Today we're going to be learning about inclined planes with friction. So using our past knowledge of inclined planes and a little bit of new information on friction, we should jump into these right away. Let's get started. So a little background information on friction. Friction is basically a force that acts on a system. You could think of it like the friction from the street slows down the movement of a car. Two basic forms of friction are kinetic and static friction. Kinetic friction is the friction force that acts on a system while it's moving, therefore slowing the movement down. And static friction is the force the system has to overcome in order to move in the first place. Both can be found using the same equation, which is friction force equals mu times normal force. Mu being the coefficient of friction. So before we jump into inclined planes, we're going to start with a friction problem on a level surface. So as you can see here, we have a 10 Newton box resting on a table with an applied force of 5 newtons to the right. And the table has static friction of 0.4 and kinetic friction of 0.3. So we're going to use our equation force of friction equals the coefficient of friction times normal force to solve for the net force of the problem. So first we have to figure out even if the box even moves. So when we say that, we think of static friction and how the applied force has to overcome static friction in order to move the system. So as you can see here, we set it up where the force of static friction is equal to the coefficient of static friction times normal force. And so we just plug our numbers in. So 0.4 is the coefficient of static friction, and 10 is the normal force, 10 newtons I should say. And we get a static friction of 4 newtons, static friction force. So we know that the box moves because the system has an applied force of 5 newtons on it, and that 5 is more than 4 newtons, which is the force of static friction, so we know it's going to move. So now that we know it's going to move, we can calculate the force of kinetic friction. And basically we're going to do the same thing as seen here, and instead we're just going to plug in the coefficient of kinetic friction, which is 0.3. And the force of kinetic friction is going to come out to 3 newtons. So when we draw this out here, the force of kinetic friction is going to be going this way, 3 newtons, and we're going to get a net force of 2 newtons.
So this is the same problem that was before, except we changed one variable, a couple of variables. The static friction changed to 0.6, so you're going to use the same equation that you did last time, and you're going to take 0.6 and multiply that by 10. It's going to give you an answer of 6 newtons. That's going to show that you cannot overcome the force on the system, so the system remains unchanged. So therefore the system doesn't move, and finding kinetic friction is irrelevant.
So now we're given a problem where a box with a mass of 10 kilograms is on an inclined plane at an angle of 58 degrees to the horizontal, and the plane has a coefficient of kinetic friction of 0.84. So we're going to find the net force in the x direction of the inclined plane. So first what we want to do is solve for the friction force. And to find that, we're going to need the normal force. So what we're going to do is draw out our triangle as seen here and use some trig functions. Cosine of 58 degrees is equal to the adjacent side, or the normal force, over 10 times 9.8, which is 98 newtons, the weight of the box. So after we solve through, we can figure out that our normal force is approximately 51.93 newtons. So now that we have our normal force, and we know that the coefficient of friction was given to us, we can plug those both into the equation as seen here, and it should come out to give us approximately 43.6 newtons of kinetic friction force. To find the force of gravity in the x direction, which is going against the force of friction, we are going to also use the triangle seen in the model, and we're going to plug in our trig functions and our numbers, and we're going to come out with sine of 58 is equal to opposite, which is gravity in the x direction, over 98 newtons. And once we solve that through, we find that gravity in the x direction is approximately 82.32 newtons. So now that we have the force of kinetic friction and the force of gravity in the x direction, we can combine these two numbers, or sum your forces, and we come out with 82.32 newtons minus 43.6 newtons. And that gives us a net force in the x direction of 38.72 newtons.